tonight. We're going to explore one of the most unsettling mysteries in all of science. Look up at the night sky on a clear evening, away from the blinding glare of city lights, and you are confronted with an ocean of stars. The Milky Way stretches across the blackness like a luminous river of cosmic dust. Is a sight that has inspired humanity for millennia, evoking a deep sense of wonder and a profound question that has haunted every generation. Is there anyone else out there? When we apply modern science and mathematics to this question, the numbers tell us that the universe should be teeming with life. There are an estimated 200 billion trillion stars in the observable universe. Our own Milky Way galaxy alone contains somewhere between 100 billion and 400 billion stars. Each one is a potential sun, and current astronomical data suggests that nearly every single one of them hosts planets. Billions of those planets sit inside the Goldilocks zone, the habitable zone where liquid water can exist on a planetary surface. Billions more possess the right size, the right chemistry, and the right stable conditions for life to emerge. Furthermore, the universe has had 13.8 billion years to play with these numbers. It has had eons for life to spark, to evolve, to develop intelligence, and to construct civilizations that cross the interstellar void. Yet, when we point our most advanced instruments toward the deep dark of the cosmos and listen, hear absolutely nothing. No radio transmissions cutting through the static, no signs of massive engineering projects on a cosmic scale, no evidence of intelligence anywhere except right here, on this fragile patch of blue soil we call Earth. Just complete, deafening, absolute silence. For decades, scientists have called this discrepancy the Fermi paradox if life should be abundant. Where is everybody? We've comforted ourselves with the idea that we just haven't looked hard enough, that the signals are out there waiting to be found, or that civilizations are simply hiding. But when you subject the latest astronomical data to rigorous probabilistic modeling, a much more terrifying conclusion emerges. This silence isn't a temporary technical limitation. This silence is a definitive data point. This silence proves we are completely, utterly alone. By the end of tonight, you're going to understand why the cosmic sonata, the Great Silence, might be the most significant and terrifying discovery in human history. We are going to break down the cold math behind the absence of alien life, explore the concept of the Great Filter, and look at how the unforgiving laws of physics quarantine intelligence. Before we dive into the deep dark of the cosmos, if you love exploring the hidden mechanics of space and existence as much as we do, take a second to like this video and subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Welcome back to Dark Matter Nap. Now settle in, let the quiet take over, and let's begin to understand why the silence is a proof of loneliness rather than just a lack of looking. We have to look at the sheer scale of the cosmos and the time available for life to move through it. Let's perform a mathematical breakdown. If we look at just our own galaxy, the Milky Way, it is roughly 100,000 light years across. That sounds vast beyond human comprehension, and it is. Let's look at how quickly a technological civilization could colonize it. Imagine a species that arises somewhere in the galaxy. They develop technology similar to ours, but continue to advance. They build starships that travel at a conservative pace, not at the speed of light, but at just 1% of the speed of light we explored previously. Traveling at 1% of the speed of light is incredibly slow in cosmic terms, requiring about 400 years to reach the nearest star systems. This civilization sends out colonial ships to neighboring stars, establishes colonies, allows those colonies to grow for a few thousand years, and then sends out new ships from those colonies. How long does it take for them to spread across the entire 100,000 light-year span of the Milky Way? Math reveals that it takes roughly 10 million to 50 million years. Now, 50 million years sounds like an eternity to a human being. Set on the cosmic clock, 50 million years is a blink of an eye. The Milky Way galaxy is over 13 billion years old. The solar system we reside in is 4.6 billion years old. This means that the galaxy existed for nearly 8 billion years before Earth even formed. A single intelligent species had arisen in our galaxy just a fraction of a percent earlier than us, say. 100 million years ago, they would have had more than enough time to colonize every single star system, harvest every asteroid belt, and blanket the galaxy in communication networks. They should have crossed our solar system multiple times before humans even learned to walk upright. When you look at the sky, you shouldn't just be looking for faint radio signals from a distant planet. If the universe naturally produces intelligent life, the physical evidence of that life should be surrounding us. The night sky should be ablaze with the infrared signatures of Dyson spheres, mega engineering projects, and automated probes tracking the stellar pathways. When we look at the cosmic record, we see a pristine, untouched wilderness. The planetary systems we observe are chaotic and natural, showing no signs of artificial restructuring. The interstellar medium is completely clear of artificial artifacts. The galaxy looks like an empty room where the lights have never been turned on. And when an empty room remains empty for billions of years, the most logical conclusion isn't that someone is hiding under the rug. The most logical conclusion is that the room is vacant. When faced with this vacancy, evolutionary biologists and astrobiologists point to a fundamental concept that explains why the transition from an empty planet to a technological civilization is a mathematical miracle. This is the concept of the Great Filter. The Great Filter suggests that somewhere along the path from non-living matter to a spacefaring, multi-planetary civilization, there is an incredibly difficult barrier, a step that is so highly improbable that almost no species can cross it. This filter can lie in our past, or it can lie in our future. Let's examine the possibility that the filter is behind us. Let's look at the absolute absurdity of the first step of abiogenesis, the transition from raw chemical elements to living, self-replicating organisms. We often hear in popular science that life on Earth started almost as soon as the planet cooled down, implying that life is an inevitable chemical consequence given the right ingredients. But this is a profound survivability bias. We are here to observe that quick start, because if it hadn't happened quickly, we wouldn't exist to measure it. When you look at the raw molecular probability of creating a single functional protein sequence by pure chance, the numbers are devastating. A basic protein consists of a chain of about 150 amino acids. The number of possible configurations for such a chain is roughly $10.195. To put that in perspective, there are only about $10.80 atoms in the entire observable universe. For raw chemicals treading in a primordial ocean to randomly align into the exact sequence required to create life, to develop a genetic code, and to build a self-replicating mechanism like DNA, requires a sequence of luck that borders on the mathematically impossible. Might have simply won a lottery against odds so staggering that it only happens once across trillions of galaxies. And even after life begins, it hit a massive wall on Earth that lasted for nearly 2 billion years. The transition from simple prokaryotic life like bacteria to complex eukaryotic life cells with internal organs and nuclei took 2 billion years. Life on Earth remained stagnant, a microscopic slime completely incapable of intelligence, the merger that created complex life, where one primitive cell swallowed another bacterium and, instead of digesting it, formed a symbiotic relationship that became the mitochondrion. Was a freak, accidental mutation. It happened exactly once in 4 billion years of Earth's history. This single-cell merger is the Great Filter. Then the universe is a sprawling graveyard of slime. Trillions of planets may be covered in primitive bacterial mats, worlds that will remain completely silent from their birth to the day their host stars die, because they lack the biological architecture to ever develop a brain. But let's assume a planet beats the staggering odds of abiogenesis and complex cellular evolution. Let's assume complex organisms emerge. Surely, Over hundreds of millions of years of natural selection, intelligence becomes an inevitable survival strategy. Right thighs is the second great deception of evolutionary biology. We view human intelligence as the natural crown of evolution, the ultimate peak that all life strives toward. But when we look at the history of life on Earth, intelligence is not a common adaptation. It's a highly bizarre, incredibly expensive evolutionary fluke. Consider this: Earth has hosted billions of distinct species over the last 500 million years since the Cambrian explosion. Flight has evolved independently multiple times in insects, birds, mammals, and reptiles. Eyes have evolved independently dozens of times across different phyla. Camouflage, venom, armor, and echolocation have all appeared over and over again because they are highly efficient, reliable solutions to common environmental pressures. But high-level technological intelligence, the ability to abstractly conceptualize calculus, build radio towers, and look at the stars with curiosity, it has evolved exactly once in a single lineage of primates during a tiny sliver of geological times, or 150 million years. Dinosaurs dominated this planet. They were spectacularly successful, adapting to every climate and ecological niche. Yet, in all that time, not a single dinosaur developed a brain large enough to construct a wheel or light a fire. Evolution does not care about intelligence. Evolution cares about survival and reproduction. And a massive brain is a terrible biological investment. The human brain makes up only 2% of our body mass, yet it consumes over 20% of our daily caloric energy. It requires a dangerously prolonged childhood, leaving offspring vulnerable for years while the neural networks form. For most species throughout evolutionary history, a larger brain is an energetic liability that leads straight to extinction. Humanity required a highly specific, precarious sequence of environmental pressures: the drying of African forests, the transition to bipedalism, the mastery of fire to pre-digest calories for brain growth, and the development of complex vocal cords, just to tip the scales in favor of a larger intellect. When you look at the great silence of the universe, you are seeing the result of this intelligence trap. Intelligence is not the destiny of life. It is an evolutionary anomaly. The cosmos may be rich with biospheres, packed with magnificent, complex predators and strange, beautiful organisms swimming in alien seas, but none of them are looking back at us. They are trapped in the endless, unthinking cycle of nature. Now, let's explore the most chilling alternative. Let's assume that life breaks through the biological filters. Let's assume a planet scales the lottery of abiogenesis, complex cells, and the evolution of a technological brain. The species builds cities, masters electricity, and begins broadcasting their presence into space. This brings us to the dark side of the great filter. The filter is in front of us. The barrier to interstellar civilization lies in our future. It means that the moment a species develops high-level technology, they simultaneously create the means of their own absolute destruction. The silence we hear from the stars isn't because life fails to start, but because life inevitably executes itself the moment it gains the power to do so. Consider our own historical trajectory. Humanity transitioned from basic radio communications to the development of thermonuclear weapons in less than a single century. We unlocked the fundamental energy binding the atomic nucleus before we even developed the political maturity to stop killing each other over invisible borders. During the height of the Cold War, our species sat on a knife's edge, one mechanical glitch or panicked decision away from wiping out our entire industrial civilization in an afternoon. And nuclear weapons are just the first rudimentary filter of a technological species. We are currently entering an era where the barriers to existential risk are becoming completely democratized. In the next few decades, advanced genetic engineering, synthetic biology, and nanotechnology will move from top-secret military laboratories to standard commercial tools. A single rogue actor, an extremist group, or a malicious individual with access to a desktop bioreactor could design a pathogen with the incubation period of HIV and the lethality of Ebola, releasing it into a globalized world and ending human history in a matter of months. Furthermore, we are actively constructing a cognitive competitor, artificial general intelligence. We are racing to build systems that think faster, analyze deeper, and possess greater strategic capabilities than the biological brains that created them. An unaligned superintelligence takes control of our global infrastructure. It could view biological life as nothing more than an inefficient arrangement of carbon atoms, turning the lights out on humanity without a shred of malice. When we look out at the 200 billion stars of our galaxy and hear nothing, we may be looking at a cosmic graveyard of civilizations that ran out of time. The lifetime of a technological species might be limited to a tiny, microscopic window, perhaps a few centuries before their energy consumption destabilizes their climate, or their weapons catch up with their wisdom. They flare up like a brief match in the dark, and then they fall forever silent. But let's step away from biological and technological assumptions for a moment. Let's look at the literal, physical chemistry of our universe. Here is a powerful scientific argument that suggests our solar system resides in a unique cosmic sweet spot. While the vast majority of the universe is a physical desert completely hostile to the emergence of any life at all, this is known as the galactic habitable zone theory. Just as a planet must orbit at the correct distance from its host star to remain habitable, a solar system must reside at the correct distance from the center of its galaxy to foster a technological civilization. The center of the Milky Way galaxy is an incredibly violent, high-energy environment. It is packed with an immense density of stars, screaming with cosmic radiation, and dominated by a supermassive black hole. Galactic core, supernova occur with terrifying frequency. If a planet develops a biosphere near the core, a neighboring star will inevitably go supernova every few million years, completely stripping away the planet's ozone layer, boiling its oceans, and blasting its surface with lethal gamma-ray radiation. Life in the center is constantly reset to zero before it can ever develop complexity. Inversely, if you look at the outer rim of the galaxy, the environment is peaceful, but it lacks the basic building blocks of life. The early universe consisted entirely of hydrogen and helium. Every heavier element on the periodic table, carbon, oxygen, iron, silicon, and gold, had to be forged inside the crucibles of dying stars through nucleosynthesis and scattered across space via stellar explosions. Astronomers call these heavier elements metals. The outer edges of the galaxy suffer from low metallicity. There simply aren't enough heavy elements out there to form solid, rocky planets like Earth. The stars on the rim host nothing but massive, low-density gas giants, worlds with no surfaces to walk on, no heavy metals to mine, and no chemical foundation to spark organic life. Humanity lives in a highly specialized, narrow ring of the galaxy. We are far enough away from the violent core to avoid radiation sterilization, yet close enough to have inherited a rich mix of heavy elements from previous generations of dying stars. If the galactic habitable zone is as narrow as current models suggest, then vast swaths of the night sky are empty not by choice, but because they are chemical wastelands where the ingredients for a technological mind simply do not exist. And within the galactic habitable zone, the physical requirements to sustain a stable biosphere for the billions of years required to evolve intelligence are astronomically precise. When we look at our own solar system, we realize that Earth is not a standard, run-of-the-mill planet. It is a highly specialized cosmic anomaly supported by an intricate network of protective shields. This is the foundation of the rare Earth hypothesis. Examine our first shield, the magnetosphere. Earth possesses a highly unusual, rapidly spinning liquid iron core that acts as a massive dynamo, generating a powerful magnetic field around our planet. This field deflects the relentless stream of high-energy charged particles screaming from our sun, the solar wind. Without our magnetosphere, The solar wind would have slowly sandblasted our atmosphere into deep space eons ago, turning Earth into a cold, dry, dead desert exactly like Mars. Yet, creating a stable, long-lasting planetary dynamo requires a massive collision event early in a planet's history to melt its interior and kickstart the core mechanics. Our second shield is our sister planet, Jupiter. Jupiter is a gas giant with a mass 300 times greater than Earth. Located in the outer solar system, its massive gravitational well acts as a cosmic vacuum cleaner and shield. It attracts, deflects, and absorbs the vast majority of dangerous comets and asteroids that scream inward from the Kuiper Belt and the Oort cloud. Without Jupiter sitting out there as our gravitational guardian, the impact frequency of extinction-level asteroids on Earth would be up to 1,000 times higher. Complex life would be wiped out every few million years, never finding the geological stability required to evolve higher consciousness. Our third shield is our unusually large satellite, the Moon. Relative to the size of its host planet, Earth's moon is the largest satellite in the solar system. The gravitational drag of the Moon acts as a stabilizer for Earth's axial tilt. It keeps our planet's wobble locked in place, ensuring a stable, predictable climate over hundreds of millions of years. Without the Moon, Earth's axis would tilt wildly over time, causing the poles to face the sun directly, melting ice caps overnight, throwing the climate into violent, unlivable extremes, and shattering the fragile evolutionary pathways of terrestrial life. The list goes on: plate tectonics, recycling carbon, the presence of a stable G-type star with a long lifespan, the exact placement of water delivery via ancient asteroid bombardments. When you multiply the probabilities of all these structural shields occurring on a single world, the final number drops below 1 in a trillion. Earth is a masterfully tuned clockwork mechanism, an exception to the cosmic rule of chaos. When astronomers search for habitable exoplanets, they get incredibly excited when they find worlds covered in liquid water. They call them ocean worlds or water worlds, planets where a global sea wraps around the entire globe with no continents in sight. In popular media, these are depicted as paradise planets where life must surely flourish. But when you analyze the physics of technology, you realize that a water world is a tragic, inescapable dead end for intelligence. Water world is a physical prison that guarantees a civilization will remain permanently silent and primitive. Imagine an intelligent species that evolves in a global ocean. Let's assume they develop deep cognitive abilities, complex social structures, and an advanced language perhaps similar to dolphins or octopuses, but amplified to an industrial degree. They are highly philosophical, curious, and creative. But how do they build a radio tower? How do they build a spaceship? They cannot. Technology requires metallurgy. Metallurgy requires fire, requires an atmosphere rich in oxygen and a dry environment where combustion can take place. You cannot forge iron underwater. You cannot melt copper in an ocean. You cannot build electrical circuits, refine chemical propellants, or construct glass lenses while floating in a liquid medium. An aquatic intelligence can never progress past the Stone Age. They can never discover electricity, they can never build machines, and they can never look up at the night sky and analyze the stars because the water distorts their view of the cosmos. They are forever locked inside their biological bubble, entirely blind to the grand reality of the universe outside their waves. And astrophysical models suggest that rocky planets with a perfect balance of land and water like Earth are extraordinarily rare. Most planets with water either end up completely dry like Venus or completely drowned under hundreds of miles of global ocean due to the mechanics of planetary formations. The universe might be full of brilliant, singing, conscious alien minds swimming in dark global seas, completely aware of their immediate surroundings, but mathematically forbidden by the laws of chemistry from ever developing the tools to break through the surface and wave at the stars. Their silence is guaranteed by the ocean they call home. Centuries, science has operated under the principle of mediocrity, also known as the Copernican principle. This is the foundational philosophical assumption that there is nothing special, unique, or privileged about Earth's position, our sun, or our biology. We are average. If we are average, then whatever happened here must have happened everywhere else. But when we look at the data of the Great Silence, we discover that the principle of mediocrity is a profound logical fallacy when applied to the emergence of technological mind. In statistics, there is a concept known as an anthropic selection effect. An event is so rare that it only happens once in an infinity of space-time. Whoever arises from that single event will look around and assume their existence is normal, because they must exist to ask the question in the first place. Consider a man who wins the national lottery 20 times in a row. The odds against this are astronomical, bordering on the impossible. If he operates under the principle of mediocrity, he will conclude that winning the lottery 20 times in a row must be a common, everyday event that happens to everyone, because it happened to him. He fails to see the billions of people who bought tickets and lost, because he only evaluates his own singular reality. Look at our advanced human civilization, our global internet, our space stations, our deep understanding of quantum physics, and we assume we are just the first of many average species. We ignore the staggering mountain of coincidences, lotteries, shields, and mutations that had to fall perfectly into place over 4 billion years without a single interruption to bring us here. A single asteroid had missed Earth 66 million years ago. Mammals would still be small, nocturnal rodents scurrying under the feet of giant reptiles. If the climate of Africa hadn't shifted dynamically 3 million years ago, our ancestors would have stayed in the trees, never adapting to bipedal locomotion or tool use. Our presence here is a mathematical miracle disguised as an average event. The Great Silence is the universe trying to tell us that we are not mediocre. We are the outlier. We are the extreme deviation from the norm of empty, unthinking matter. Let's explore a final, definitive mechanism that ensures even if civilizations manage to emerge in distant sectors of the universe, they can never bridge the gaps to break the silence. This is the quantum quarantine. We often imagine that advanced civilizations will inevitably discover shortcuts through space-time wormholes, tachyon transmissions, or quantum entanglement communication networks that allow instantaneous contact across light years. We assume that the silence we hear with our primitive radio telescopes is simply because the rest of the cosmos has moved on to a higher, faster band of quantum information. Quantum mechanics contains a brutal law that forbids this, the no communication theorem. While it is true that quantum entanglement allows two particles to become linked so that a measurement on one instantly determines the state of the other across an infinite distance, this phenomenon cannot be used to transmit actual information. The result of a quantum measurement is always inherently random. You cannot choose what state to send. You can only observe a correlation after you compare notes through classical light-speed communication channels. The universe has written the speed of light $c$ into its most fundamental subatomic fabric. It is not a technical speed limit that can be bypassed with a more advanced engine. It is the fundamental speed of causality itself. Because of this hard causal barrier, if a civilization arises in a galaxy 100 million light-years away, they are completely locked inside their own historical pocket. If they send a distress signal or a grand broadcast, that signal spreads across space, losing energy at an inverse square rate. By the time it crosses the intergalactic void to reach our telescopes, its amplitude is far below the natural static noise generated by the quantum fluctuations of empty space. The quantum foam of the vacuum itself acts as a cosmic sponge, dampening, scattering, and erasing the signals of technological life across extreme distances. The universe does not require physical walls to maintain its quarantine. It uses the uncertainty principle and the decay of information to ensure that every intelligent spark remains blind, deaf, and completely isolated within its local sector. This leaves us with a profound existential realization. The Great Silence is not a technical problem to be solved. The Great Silence is a mirroring reflection of our own unique reality. It is a proof that we are completely, utterly alone. It's incredibly easy to find this conclusion depressing. When you look at the cold numbers, the trillions of miles of empty, hostile space, and the accelerating void of dark energy that is slowly tearing the cosmos apart, it feels like our existence is completely insignificant. We are brief sparks of conscious matter in an infinite ocean of darkness. Temporary, fragile patterns destined to be swallowed by an absolute freeze. Feel like abandoned children in a dark, empty mansion. But there is an entirely different way to view our place in time. The very fact that the universe is tearing itself apart, the very fact that this cosmic sonata defines the night sky, makes our presence right now extraordinarily rare, precious, and sacred. We live in the absolute golden window of cosmic history. We live in an era where the universe is still close enough to be seen, mapped, and understood. We are the universe noticing itself. We are the precise configuration of stardust that developed brains, eyes, consciousness, and the capacity to look back at the void and decode its laws. An empty universe that is observed, measured, and comprehended is fundamentally different from an empty universe with nobody around to notice it. Presence gives the emptiness meaning. If we are the only technological mind in existence, then the entire burden of meaning rests squarely on our shoulders. We are the sole witness to the majesty of creation. We are the only custodians of reason, love, art, and curiosity in a 93 billion light-year expanse. This realization shifts our perspective away from cosmic insignificance and places an immense cosmic responsibility on our species. We destroy ourselves through technological arrogance, nuclear war, or ecological neglect. We aren't just ending human history. We are extinguishing the only light of consciousness in the entire universe. We are turning the lights out on reality itself, leaving the cosmos to spin through eternity in absolute, unthinking darkness. Our physical starships may never leave this immediate solar cradle. We may be destined to live out our entire history as a species within the confines of a few light years. But our minds, our curiosity, and our science can span the entire cosmic horizon. We do not need to conquer the stars to belong among them. Sitting on our tiny pale blue dot, trapped by the laws of physics, we have still managed to understand the very mechanics that govern the birth and death of the cosmos. And that is not nothing, that is everything. Thank you for joining me tonight on this massive, late-night deep dive into the terrifying physics of cosmic emptiness here on Dark Matter Nap. If this exploration challenged the way you look at the night sky, or made you appreciate how precious and fragile our existence truly is, please take a moment to like this video and subscribe to the channel. Support helps us continue to create these deep, quiet journeys into the mysteries of existence. The next time you look up at the night sky and feel overwhelmed by the sonata, do not be afraid of the quiet. Appreciate those stars not as destinations we will someday claim, but as beautiful, temporary lights shining briefly in a vast, expanding dark shining just for us, just for now. Sleep well tonight, knowing that you are the conscious eyes of an expanding universe. Good night, and may your dreams reach far beyond the uncrossable horizon.